Alright, so before we get too far into derivatives, we want to continue kind of what we ended section 2.2 on, which was kind of an application of derivatives. Why do we care about derivatives? Before we get deeper into rules and deeper into analyzation of derivatives, let's kind of motivate where we're going in this class. And that's what section 2.3 is about. It's a motivation as to why derivatives are so important. Derivatives are rates of change. The derivative is a slope of a tangent line. A slope is a rate of change. Well, in particular, we're going to learn about a couple different rates of change. It says find the average rates of change of functions over an interval versus find the instantaneous rate of change. So there's two different ones right there, average versus instantaneous. And then it says we're going to actually do nice applications as well. We're going to see velocity, which is a rate of change. We're also going to see marginals. There's marginal revenue, cost, and profit. So we're going to bring this back around to some business functions, some physics functions, and just in general, rates of change. So it says we look to extend our understanding of a derivative. Remember, two applications of derivative have been, the first one being slope. The derivative of f is a function that gives the slope of the graph of f at any point. So the derivative is the slope at any given point, and a slope is also a rate of change. So the derivative of f is a function that gives the rate of change with respect to x at the point x, f of x. Slope, rate of change, exact same thing. So I want you to remember, take a step back and remember what we had for the derivative. When we were finding a derivative and we had a function and we were looking at that function, we were looking at, started off with what's the slope between two lines? And what that got us to was what's the slope at an actual point itself. So if you remember, the slope between 2 points was called the secant line. Okay? And then the slope at 1 point is called the tangent line. So what we did was we took the slope between 2 points, a secant line, we moved those 2 points together, closer and closer together, and that gave us the slope at a single point, which was a tangent line. So remember, secant line, tangent line. If you remember, what was the formula? Well, the formula for the slope at a secant line was the change in y over the change of x. That was the difference quotient. To make that the slope of the tangent line, what we did was we brought those points closer and closer together. So that was our definition of a derivative, the definition of the slope at a point, the definition of a rate of change at a point. It came from taking the secant line and bringing those points closer and closer together, making it the tangent line. Well, we're going to learn those two things right now. The first thing we're going to learn is the average rate of change. Average rate of change is the slope of the secant line. It's super easy. Average rate of change is just change in y over change in x, y2 minus y1 over x2 minus x1. That is the average rate of change. And we're going to compare that to instantaneous rate of change. Instantaneous rate of change is the derivative. Instantaneous rate of change is the derivative, which is the slope of the tangent line or the slope of the graph at 1 point. So average, just do the typical slope formula. For instantaneous, you're going to do the derivative. So let's go ahead and look at this next one. It says average rate of change. The average rate of change is the slope between 2 points. Again, average rate of change is just the slope between 2 points. It's nice and easy. It's the change in y over the change in x. This is what you guys know as y2 minus y1 over x2 minus x1. Of course, it doesn't need to be x's and y's, especially in application problems. It's not at all. So what you do is you look at this picture right here, and all they're saying is, if you look at this line that they're looking at, again, that would be the secant line. The line between the 2 points is all you're doing is finding the change in y, which is f of b minus f of a over the change in x. And that change in x is b minus a. And so this is just your typical slope formula, which is f of b minus f of a, or the change in y over b minus a. Or likewise, you could say this is the y2 minus y1 over x2 minus x1. Okay, this is your typical slope. This is your average rate of change. I'll do A, R, O, C, standing for average rate of change.